Gonna share my screen. Good evening, class. Today is Monday, 7/6/2020. It is 7 p.m. now. We're gonna start the lecture. But before I start the lecture, I'd like to know if you have any question. Does anyone have any question? Okay, so you can also ask question sometimes when we are finished with the lecture, and we can just go to the lab activities. So you're seeing my screen right now, and today's topic, we're gonna just discuss strains, chapter 6 of the textbook, and also chapter 7, which is a file IO. And then this week is week 4 of the 6-week class. So we passed 3 weeks, and then we're on the 4th week. Today is Monday. We are doing chapter 6, string, and also chapter 7, files. File IO, file management system, is an essential part of the operating system, as well as Python programming, as well as any other application that works with file management systems, file IO, or file system. So, and then this Wednesday, we're gonna continue on files and also cover list. So this week we will cover a string, chapter 6, files chapter 7, and list chapter 8. And we do have some assignment also that are due tonight from last week. There's going to be assignment for Wednesday, and there's going to be assignment next Monday. Please make sure that you do all the assignments so you get full credit for all of them. In addition, tonight I have a quiz right after the lecture, which is going to be around 9 o'clock. After you take your break, we're going to just have a quiz. Please make sure that you attend. Otherwise, you're going to lose some points if you don't take the quiz. The quiz is only at the lab time activity. It will be available at the lab time, and after that one, there's no quiz that is going to be available. But then also moving forward, because this is a short summer 6 weeks course, I want to cover as much as we can. In order to do so, we need to basically have some of the lab activities to do certain assignment that are due. I don't want to just keep assigning 2 or 3 assignment per week. I want to do, or per day, I want to just do some of them at the lab times, so you have plenty of learning opportunity to complete the course and get a good outcome out of it. So tonight for the agenda, I have this page which is going to describe what we are going to cover. We're going to cover chapter 6, which is a string, and then also we're going to cover chapter 7, which is a file IO. And when we do that one, we're going to first describe what a string is. Basically, a string is a sequence of characters and sequential order that it comes in. For example, this word will have W-I-L-L. That's a sequence of 4 characters. Similar to the cover, similar to the following. All of these are strings. And when it is a combination of one or more strings or one or more characters in a sequence, that's called a string. And then you have used a string data types on other programming languages. In Python, it is called str, and the package that supports it is called a string. In addition, there's a string data type that has a lot of methods and Dundrum, and then a lot of other magic method and exceptions and other things that we will go through tonight. You will learn it. File I/O management is going to be something of more interest because you have to, whenever you either deal with some sort of file. Everything in operating system is considered a file, whether it's a file, whether it's a directory, whether it's a pipe, whether it's a device. The operating system handles it as a file, and then it has a file handle for it or file descriptors. Normally, there's at least 3 file descriptor that everyone has used, which is a file descriptor for reading, and then for basically standard N for just doing keyboard or data entry part of it. A standard output, which is for displaying, whether it's going to be on the VGA screen, the console, or a terminal, or to a file, you're writing it, and then the standard output, which is the standard error, which is the error files that are being sent. So standard N, a standard out, and a standard error. A standard N and the file descriptor is normally 0. The standard out is file descriptor 1, and then a standard error is file descriptor 3. I could show you that one on Unix machines much easier. Of course, and Windows is the same thing. So the file descriptors that are here, if I just do a dir command, it is just reading from a file system that is reading the data, and right now the display standard output is on the screen. If I send it to a file called T, now the redirection, this is file redirection, greater sign, and saying that send and create this file T. And if I just say type T, that it just display that one, delete T. So everything that you do with file management, we will cover, but we will write Python programs to read files and text mode, text-based files, and as well as binary files. So we could just have some images to read and write to it, and how we do the file handle. There's something on Python is called file context manager, which is with the statement of Python. Once you use that one, automatically Python take care of the file descriptors, opening it and closing it within the file context manager. And I'll go over that one as well. So these are the things that I have covered as what we're going to discuss. And we're going to do all of these methods here that are discussed, and then some of the variables, some of the Dunder magic types, and then the OS modules. We're going to cover as many of them last time we did. We're going to just continue on that one, and then the import Cis modules, some of the methods that are with Cis modules, what they are and how to use them. I'll cover all that right now. And then import the string is another module that we will discuss some of them, and some of these built-in variables or unknown data types, like for example, the ASCII lowercase, ASCII uppercase, and caps, words, digits, and hexadecimal, octal numbers, and all that things we will discuss. And then also how to get help on, for example, when you download, when you import this string module, you can do help on it, and you could get documentation on it. For example, a string dot one of these one will just show letter ASCII and lowercase letters, and ASCII and uppercase, and so on, octal digit. We will go a number of them. What are the printable characters that we have to do is the ordinary type, the char, chr, all of that we will cover that one. And then let's go jump into the script that I wrote here for you to learn. So I'm going to clear my screen here and let's see. And here, if I just do cd to Pasadena, pasadena.edu, let's change directory to that. And then I go to my summers CIS 012 summer 2020 core directory. And here I have a lecture directory. Under the lecture, I have chapter 6 and 7 for tonight. So let's say we go chapter 6 and we cover all these ones. In order to do it, let's just say I call it a string1.py. So if I just use Adam, string1.py, like Notepad, Adam is text editorial, but the nice thing about Adam, it has different font colors, and it has a nice indentation that is automatically take care of your indentation for Python, and you can open multiple files at the same time, and it's a much easier look and feel for it, and it is a good thing to do comparing to like a Notepad opening it. So I'm going to open from now on either on Adam or show you on PyCharm. So the PyCharm, we installed it last time and we can use it starting today or Wednesday. Today I will demo a lot of it on Adams, so you're getting familiar with it. When you open Adams, you see you have a menu, but you have a welcome page by default. This comes in, and then every other ones that you have opened there. So I don't need this welcome, and then this welcome guide, I don't need it. So I'm looking at this file, and the name that I gave it is incorrect because that's not the file that I want to open. I just open a new file. So if you gave a name that doesn't exist, it just open a new file. But I want to just open one of the file that is called a string one, not ATR one. So I'm going to go here and just click on open. The nice thing, it has a menu, so it was opening it. Now this ATR one, we don't need it. We close it, say don't save it there. So this one is basically show you how to write Python script to manipulate a string. So here I define a string. For example, a string by definition in Python is data types is a string and is a sequence of characters, basically. A sequence of characters because like for example, the variable here, food, when you learn how to declare variables, you know that you're going to come with lowercase names and meaningful names that is kind of easily understood what is this takes as a value. So food, and then even though a cake is not food, but you can just say, food, and then give a definition of cake or some other kind of burger or something. Doesn't matter what you define the value for it. But once you define this string food, which is a variable string, if I print the data type of this one, basically it is saying a string. So, and then here is the string cake, but each character has an index. Index 0 is the first character, index 1 is the second character, and so on. And then you can also use the reverse number. Starting with -1, you're pointing to the last character. -2 is the last character from the last character, and next to the last character, left to the next character, and so on. And then you can print that same values by saying food sub 0, and you get the C. And food sub 1, you will get the A. Food sub 2 will give you the K, and food sub 3 will give you. Because of the start with 0, even though it's 4 characters, the last character is the linked -1, which is if the length of this one is 4 characters, then it will just print that one. So let's say we run it, here I'm just going to clear my screen and do this, and then now if I just type that a string one dot py, that is basically the script. So if I want to execute it, since I did not give any shebang pound at the top, I could just say Python here, and then even with the .py, sometimes on Windows, it already associated as a Python script. So as you can see, the way that the script is written, food is, when I say print food, it prints cake, and right here. Then the next one, food sub 0, the first food sub 0 is C, and then food sub 1 is going to be A. Whatever is the index for each one of them is going to print it. And then -1, it goes backward. -2 is K, and -3 is A, and -4 is C. If you go any number higher than the last number of the index, says, like for example, if you print food sub 4, it gets out of range. And so as an example, if I just go to Python here and I say food is equal cake, I need to put it within, I cannot say like this cake, because that's does not know what is this cake as a value. This cake is not defined. If cake was already pointing to another string called a cake, then that would make sense to just say that word. But right now we're just defining it, either do a single quote or double quote. This also does the same thing. Okay, so this does the same thing. If I just have another F, and that one is called cake here, I could have just said food is equal F, it would not complain. But if I say food is equal N, which is not defined, it will say N is not there. Now if I say N is equal F, and then say food is equal N, it will do it. So now look at the type of food, and the type of N, and the type of, what was the other word, F, N, and F. So all of these are a string data type. And with these ones, when you do a dir of food, you see that these are the methods that you can use. Anything without these two underscore are the methods that you can use them. And then these methods, or magic method or dunder, these are underscore this. Like for example, this is allowing you to add to a string together. So if I just have a string 1 is equal Wahid, and then a string 2 is equal Lutfi, and then I say print S1 comma S2, that would do the same thing there. But if I need to just print a comma next to them, and then I want to do last name first and then comma, then I need to do a comma here, and then another comma, and then a string 1. So that would just do the same thing here, as if that character is kind of like a string 2 is last name, and then a string 1 is first name. I could also do the same kind of combination, saying print S2 plus, and then comma, and then plus S1, and then that would do the same thing. Notice that when you do a plus, it is doing concatenation. So this concatenation and then this dundrum add is the same thing. So I could say, for example, S1 is going to do that, S2 is there. So I could say S1 dot underscore add underscore, and then do S2 with it, it will just do the same thing. And if I need a space, obviously I have to add that one here. Say, for example, S1, and then I could just maybe do a dot let me just do a dot, and then underscore underscore at underscore underscore, and then within this I could do a space here, one space, and then dot and that. So now I just made it string 1 followed by a space and followed by add and then a string 2. And then if you just switch the order, make this one is 2, it doesn't care. Python doesn't care. It says, okay, he wants to write Lutfi before Wahid. So, and then instead of that, you could just say comma here, and then that could just do the same thing that you did above here. And then if you just want to say, now because we say these methods are object-oriented, if I want to just do this word, and then I say to upper, I could do the same thing, and let's say to up, not to upper, just upper. Upper is going to convert everything to uppercase. And if I want it all lowercase, it's just lower. And then it doesn't matter. Sometimes you say, I want it lower, but then let's say I just use that method. I want to just cap uppercase. And then if I want to do it like capitalize, I could do that to say the first letter there. And then if I want to change the title, for example, to make it a title. So some of these methods, you don't want to just keep growing like this, because this one, we already said to lower, to upper. If we just need to do only a title, we don't need to do those other ones. So I just show you that because object-oriented, sometimes the method could grow as big as you want, and then you could do the comparison. So if I do a dir of S1, for example, you can see there's a method upper, translate, title. So if I just say, maybe I write a book called My Book, and then the name of the book is The Direct Way, and actually the direct way to Solaris Express. Let's say you write a book and that's your title. Then if I just say my book, I could just get it. And then even if I just did not capitalize it, I could just say my book dot title, and then just convert it to all like a title. You can see that 2 is also changing there. So if I just, for example, say a message is equal, I'm going to put a message, say a new line, and this is line 1, and then a new line character, and this is a line 2, and then a new line character, and this is a line 3, new line character. So that's good enough. Just let's say you did this, and then if you just print the message back, all it does, it just prints it exactly how the string is. If you want to get the length of this string, a message, you just say that, it's going to just count all of it. But if you want to say print message, notice the print message, because these are a special instruction to say generate a new line. So after this message, it generates one new line here, and then after the 1, it put a new line here, and after the 2, it put a new line here, and then after 3, it put a new line here, which is this. So this is there. But now if I want to define, modify an element of this one, I could not go modify this message to say, I could modify it completely this to say something different, right? So I could say this, and then just say, this is a line 4 / new line, and then let's say this is line 5, new line. So I could modify that one and now print the same message. Notice it's 5 lines. But I cannot just say, if I just say message sub 0, to get the first element, it is this one. Okay, and then I could do the T, uppercase T, and then number 2 would be H, and then number 3 would be I, and then the last one, let's say I got a length of a message would be the new line character. That would be there, but minus 1, because the length, whatever it is, linked message, so let me see what is message. Oh, so this one, it cannot be the linked message minus 1. And then this has to be, and then 1 second, let me correct that one. Print message, and then length of message, message. Is it MSG? MSG, length of message. That would give you, and then I have to do print, and then put this one within that, and then just put one colon here. So start to the end, print it, and then I forgot that last column, closing it right there. Oh, length, where did I, oh, length. So length of that. And then notice that this one is printing all of it, because you could say message this colon that would print the whole thing, because this means from 0 to the minus 1. So I could do that, or say 0 minus 1 will just do the same thing. But if I want to just see, I don't want to print this one, that's minus 1. So if I just want to do minus 2, it will be printing up to line 5 will be gone. And then if I could just say, for example, only give me the minus 2, it will just give you the 5. And if minus 1 only by itself, it will be that new line character. So if I want to just say, give me only the word this. So this is 0, this is 1, this is 2, 3, 4. So I could say message 1 to 5. And then 1 to 5, because if I did 4, I would have lost the S there. So always you're going to, when you just move to the right, you're just incrementing 1, because the last one is not going to be printed. So that's what it is. So I'm sorry, length of message is going to just show how many are there altogether. If I just say, now if I want to just modify the word this here, notice that because a string is mutable, I could not modify it, and I could just not say, let's say message sub 0 is a new line. I could not just say message sub 0 is equal, sorry, message sub 0 is equal W, for example. I could not assign it, because a string object does not support assignment, which means that any of these within these characters, if I want to modify them, I cannot modify them. It's like tuples, it's immutable. Numbers, strings, and tuples are immutable. You cannot modify each indices value, but you can assign another string, say message is equal hello world. This is just a new assignment. So now message is pointing to another one. Earlier message was pointing to this string that was there. This was the string. So if I just do this one, now a message is message value could be as a whole, could be assigned to different strings, but the indices of each element cannot be modifiable. That's what I'm saying. So if I just do message is equal hello world, then now I get the length of message. It is like 11 characters or 12 characters altogether. And then now let's just do this string here and then say print MSG. So dir of MSG, you can see there's other kind of method that are available: stripes, R stripes, and then left stripes and right stripes. Like stripes is going to take the last character and then the first character out, removes that one. So the preceding and then the prefix that are there, the first character on the left side and the last character on the right side will be removed by stripe. So if I just have the message like that, if I do message.stripe, then it will just get rid of the new line characters here. Okay, but it will not be done to the actual message. The actual message still has the word. So if I want to just do that one, I need to assign it to a message one is equal. Now message one is different than message that was originally. So when I do a stripe, I could also do R stripe, only take the right side of it. The right side of it, which means message one now does not have the new line, but the left side is still there. And if I do a left side stripe, it will only go from the left side. It will remove this new line character, but it will keep that line character there. So if I just do that now and say message one, you can say that it removes this one and that one. So L for left stripe is the same thing. Strip it there and then removes it. And then the R for right. And then if you want to do both of them, left and right, you do stripe. And then message will be, message will have no new line here, no new line. Now if I say print message one, you can see that there's new line characters after these numbers, but not before and after. And print message by itself, you can see there's a new line here, there's a new line here. So the way you manipulate it is there. For example, there's a string called start with. For example, I say message dot start with. So this will return true if the string I'm looking for actually that starts with, and then I missed the S here, starts with. And that's false because message one, the message does not start with a new line. It starts with new line, not with this. So if I just put a new line here, and then that will return true. Or I change this one, it starts with, and then change this one to message one, it still goes through because message one, it is that word. So if I say start with Wahid, it doesn't start with Wahid. And then you can also use find command to look for a string there. So message there, let's see, and dir of a message. Title join upper. These all these joins you can add to them. So this is a find command. For example, you could do the message one has that one, And then if I'm looking for how many times the word count is there, so then I could say message.count and the word is, just count for those ones. It will say that is 10 times there. If I look for the word this, and then it says 5 of them. 1, 2, 3, 4, 5. And then if I look for line 5, let's say, it should say only 1, and that's accurate. And then that's the count. You can also count for a one character and then see how many times that character is there. So if I'm looking for a letter S, you could do that as S is 10 times there. So on Unix, you have grep or word count minus C for character, minus L for line numbers, and so on. But in Python, you could write the scripts to do that one easily yourself. So let's say at this time we want to do a find command on it. So I could say message.find. If I'm looking for a string Wahid in it, it is not there, -1. If I'm looking for something never that is not there, it's going to return a -1. But if I'm looking for a string that is there, like this, it's going to just say 1, that a string is found. And if I'm looking for something else, it's going to say 3. How many times that the string is actually, it's showing the indices of it, not the occurrence. The count was showing the occurrence, how many of them. The find is going to return the index. So let's say I say a message, a greeting is equal hello name. I could say hello name and then find out, say, greeting dot find, and then if I just say name, name that is, and so this is 0, 1, 2, 3, 4, 5, 6, 7. So it should give you an indices of 7. Let me see, greeting, I typed it 7. And then similar, if I'm looking for the word G, it should say indice of 0 or -1 because the lowercase G is, actually the G is not there. But if I'm looking for H and lowercase is not there, uppercase is there. So, and that will return you the indices of it. And so in order for me to print that word and say greeting sub-0, it will give me the H that I'm looking for. And then the same thing, if you're looking for greeting and then you search for O here or comma, you say what was that one. So now if you say greeting sub-0 through 5, it will just print the word hello, because you start with the first index and then the last index, and that's how you print that one. You could also print 0 through length of the greetings, and then -1, because you just want to say the last one, unless you just get the last character also, and then that would be the length of it. And if you just did not include anything, that also means the same thing. That means the last character. Okay, so let's just go jump back to the scripting. We do have another options here that I will come back here and then do more of a string manipulation here. Notice that if I do help of like food, it will not tell me any help, but help of a string, because that's the data type, it will give you all the methods, everything. So when you just define a string to be of that type, you should not do a help on that new variable. You should still do help on the data type that is supported, like float, integer, string, boolean, and all that things. So, but you could do dir of food because this is an object. Now food is pointing to, sorry, let's see, food is still there. Yeah, dir of food should give you the methods that are available that you can still take advantage of this one. So like cake is a string, I could say food dot upper, and then now the cake will be written in uppercase. And then same thing with other commands that it's available there. There's also the F string manipulation. The F string is similar to this, like we were using, and there's a format character here also, functions. So we could say, for example, help a string format. I want to show you the difference. The format is another method for 2.7. We used to use that one, now we're using the F string. So you can do a lot of different type of string manipulation. You could see the string format and then args, and then the keyword arguments. And then this is a data dictionary. This is a string of a type that is sequential, but you can get the value of it from the cis.args. Cis, when we do import cis, there's a number of modules that are available for it. For example, if I say cis.executable, this will tell me the Python and the exec that I used. And then if I say sys.args, this one, because I did not run Python with any argument, it's just sys.args, or argv actually, it will just say it's empty. So dir of sys will give you all these other variables, and argv is one of them. So executable points to the Python version, like version info will tell you the details of what Python version you're using, 3.8.3. And you can also get a system.version. It tells you 3.8.3. That is there. And then sys.path is very important. Like all the Python path modules. So when I start the packages that I'm getting into Python, it goes to my main Python directory there. And if I have any user defined, which is the current, that will be appended, and all the side packages, all of those ones are looking for the modules. When I say import math, it will just go to this modules, and it is going to find out, especially on the Python lib directory, all the modules that are there, and then the side packages and so on. And if there's user-defined modules that it is on the current directory, it will also read it. We will talk about the relative path versus absolute path and all that things as well today. So the one that I wanted to cover for format, let's say I print the binary number. If I just say bin of 2, that is going to give me that information. But then I could just say format and then the number 2, but put it in binary mode, print it in binary. So if I just say, let's say 10, and binary is 10, 10, which is to the power of 0, to the power of 1, to the power of 2, to the power of 4. To the power of 4 is 8, and then to the power of 1 is 2. 8 plus 2 is 10, and that's how, and that one. So if I say print 4, 4, so to the power of 0 to the power of 1, so it will be just printing 100. And then because to the power of 2 is 4. And then if I just do 5 is 101, like that. So if I do the format like this, I could print out certain information. I also could say first name as equal Wahid, and then let's say I define my name Wahid and last name as equal Lutfi, and then I say um, greetings. Okay, so then I say hello, and then hello, and then I could say one string here, comma, and then another string, and then close this one, dot format, and then I say the string that I want to put the replacement, this is a 2.7 syntax with the format. So when you say this, now you're saying that I have defined a variable called last name. I could say last name here, and then comma, first name here, and then close it. So what I'm doing here, I'm using the dot, which is a join operator. This is string along with this string, but when you use the format, remember args S and arg V. So in this case, the last name will be a placeholder for this one. This is the placeholder for last name, and this is the placeholder for the first name. That will just replace that. And then now say print greetings. It will say hello, Lutfi Wahid. And if I just change the first name to say Hamid, my brother, and then run this one, the same thing there is there, but now I have to run this statement again to make sure the word says Hamid, hello, Lutfi Hamid. That's how you can manipulate the data by doing this placeholder. So there's a lot of ways you can do this one with one string, doing it on C programming language, use the sprintf statement or printf statement to do that one. But in Python, there's also something called fs string. Fs string is similar. So if I just say greeting is the same words that I have, but instead of using the format, this time on version 3.8, I'm sorry, Python 3.6 and up, anything that you're using Python 3.6 and up, you will be able to use the F string. And the F format is that you do F followed by either a double quote or a single quote, your choice. But whatever you choose as a single quote, you have to end it with a single quote. If you use double quote, you have to end it with double quote. So let's say I say F string, similar to the hello word, I'm going to put my hello here. And then instead of putting the placeholder this time, I'm just going to say last name inside here, and then first name inside the placeholder. So automatically, I don't need to put any format functions. This F is a replacement for format. That's maybe why the developer, they call it F as a string, because this is unnecessary. So this is a much smoother and nicer look at, and then that's why I like Python. When they see something that is kind of a little bit not user-friendly, they modify it and make it user-friendly. They make it better, enhancing the system. So now it says F string, hello, and then last name, first name. And now and this one is there, I print greetings. Again, this one is greetings, since first name and last name is Lutfi Hamid, and it's going to say hello Lutfi Hamid. So the string is there. Now as you say, for example, say change the title, you say title is equal senior software engineer. So let's say we give him the title that he has, and we say that's his title, and then we just say print this greeting. It's still not going to know about the title because this string here does not have anything with the title. Now if we just say here we say the string title within the braces, then we print it. Now it's going to say hello Lutfi Hamid, senior software engineer. That's how that's going to know exactly what it should say. So that if string is really powerful. And if we just change it to a single quote here, notice if I do a single quote here and double quote here, it's not going to work. It says end of line while scanning string. This is EOL is end of line. But so I just have to do this one single line and it works. And then I just run the same statement, it will say the same thing. So we cover the if string. We're going to cover other type of small function like raw and R, and then F, and then addition methods and other ones as time allows, and we go through them. So let me just exit out of this window here. I want to make sure that I am covering everything that I can within this session before we go to 9 o'clock. So string one, we already covered that one. If I go to string 1.py, you can see that it's basically drag us to the Python and do that one. So clear my screen, and then now let's do the string two. A string two, and this one I want you to learn. A string in Python is defined with data type. A string is a sequence of character. Again, I wrote. So here I define a sport as a variable, and I put the context of the value. I say I love playing soccer. So now if I want to print it, in this example, I could say print, and this is the string that I want to print. This is the value of this variable that I already defined. So this print statement, when you do a comma, it will do the same thing as this. Two strings you can also use instead of comma, a class for concatenation. So you could do that one and to print a string one plus a string two, like we were doing earlier. And then now I'm just saying print to find the length of the string. The length ln is a built-in function in Python. So all you do is pass in the string as a parameter to the length function, len function, and then you get the length of it. Here we just say the word, and here we actually use the function length with length sport as a string variable. Then we're going to do here a while statement to just say while the length of the string is not reached, which is from this one, from here to here, whatever the length is, 22 characters or 21 characters, then it's going to just go through that one character at a time, and it's just going to give the indices of it, and it's going to print it. This is for the while statement. Then I do the same thing that I did with the while statement to show you a for statement comparison. Notice on the while statement, an indice has to be 0, so it's less than the length. This condition has to be true first. Then we increment to make that condition false at some point after it reached to the out of bound for the indices. That is how the for loop ends. Otherwise, if you don't increment this one, it would be an infinite loop. So you don't want to go to an infinite loop. For the for statement, here we say for character in sports, print the indices and then the sports, and then increment this. Also, this one is incrementing one character at a time. till it finishes. For the C, we may not have to do it from time to time, depending on whether you're manipulating a string or an array of list. If you're doing a list, you don't need to do that one. I'll show you after that one. Also, next week, I'm going to cover a list. There's a lot of nice things about list manipulation. As you know, a list is mutable. List can be modified, and list also allows multiple values of the same value. That is like number 5 could be defined 10 times, doesn't matter. List is not like set. Set is does not allow duplicate values. List is a little bit slower because there's more method available to it, more data size of the data that are growing. Set and data dictionaries and tuples are faster. Tuple and sets are much faster in terms of performance, and less number of methods are available to it because tuples are immutables. We will cover all of those ones as well. And this week we're going to cover a string in file IO and list, I believe it is, chapter 8. So chapter 6 is string, chapter 7 is file IO, and chapter 7 is list. So we will cover all of that this week. And then with list, you also have list comprehension. And then we will cover that one as well. It gives you so much flexibility to do so many things in programming. And that's something that Python take great advantage of list with the list comprehension. So similar to like lambda functions. Lambda functions are functions that are not having a name, and it's one-line code, and it does certain things fast enough that you just don't need to write the whole function. In order to do that one, sometimes with less comprehension, you could do some of those methods in one line of code. So let's just go back to this example. We already clear a screen and type a string 2.py. So that's the string, and now I'm going to run it. And to run it, I just run it like that. And since the name of the extension is .py, my Windows operating system automatically associates .py with Python. It calls the Python interpreter, even though I don't have the shebang pound Python in the first line, which is normally you should have it. I could decide to do that one. That's not a problem. We do that. But on Unix, you have to do that one because a source file could be anything as an extension. If you don't say how to open it, either you have to give the name of interpreter in front of your source code to compile it, or to run it as an interpreter, or you just have to do the shebang pound and then the name of the interpreter, whatever it is, whether it's some Python, Bash, or Perl, or whatever. So, or PHP or something. So let's say in this case, the length is 22 character. And as you can see, the while statement, and it prints all of that word that I love playing soccer like this, and let's put a space on number 1, and the index number 1, which because there's a space here, and then there's a space here. Wherever there's a space, that element is printed as a space. Otherwise, it prints that character with the indices. And again, this is a string, so you cannot go modify one of the elements of the indices to have a different value. But you can just change the whole string to something else. So this is the while statement that it prints that one, and then here's the usage of, or the for statement. And again, that is the string, the script there. And I want to also post these ones for you on the Canvas, and then that way you can use this today's lab and then lab activity to practice some of these activity tonight, and then also Wednesday night to practice as well. So I'll post all of this and there, and these are scripts that are there. So now let's go to string number 3, more string 3 dot py. This one basically, and this is a simple message, nothing more than that. And then it has a counter, and initially the counter is 0. Then it goes to a for statement, a for loop. The for is going to say for I in message, which is the whole message, contain message sub 0 through length of it, or just printing this message will be the same thing. So if I just say message 0 colon like that, that would be the same thing, or a 0 colon length of message will be the same thing, and so on, right? So all of that syntax is message is equivalent to that. It's going to say if I is equal m, then I want to just count in the number of m on this message, how many times the m is there printed. So let's run it. And then notice that every time it finds the character, it just says 1, 2, 3, 4. So if I just go notepad, a string, or just Adam, string 3.py, and then change the m to some other character. I want to count another character. Let's see, on the Adams here. And then let's say like n, how many n's are there? There's 1 here, there's 2, 3, 4, at least 4 of them. So if I just do this one and save it, and then just run it again, then at this time n is going to be done in 4 times. Similar, if I just find some other string like uppercase T and there, to see if the case sensitivity is important or not, you could do that, and then do that, it just goes 1T. But if I put lowercase t, the uppercase T is not counted. So there's at least 1, 2, 3, 4 T's there somewhere. So let's say if I save this one, the uppercase is going to be ignored, and then the lowercase is 4 times. So that is how you write a small scripts or a small function. You could just return this one as a function to just give you the string. So then you could just say, if you make this as a function, and then like for example, let's say, and instead of keep going changing the character to T or E or something, you could just say def count characters. Let's say character count, C count, and then here we could just say the character that we want to count, and since this is a function, we could move this one 4 characters here, and then do the same thing. And then notice here, and the nice thing about Adams, by pressing tab, it actually moves 4 characters. Because it's a Python script, it does indentation properly. So it knows that the tab here is actually 4 space there. So now if I just say this, and just, and then here the word I have to put T, the character that the user defines. So then I could just say CC count, character count, and then I could just put the word T here, and then the next time say C count. Remember the code reusability feature of functions. You write the function once and then you can manipulate it as many times as you want. So every time I could give a different function argument, and then and just get different values. So let's say just I made for 3 calls, save it, and let's see if it has any syntax or anything that we have to worry about. So string 3, it did not do anything because on the atoms, when I did this, I did not say print it. So when we call it, it is called, but it is not, since this function is not returning anything, we just not assign it to a variable, otherwise it would say none. So we say print it, and then similar here, print it, and the last one, print. And get rid of this space here, file, and then save. Now I run it again. It just says none, none, none. Okay, so because I'm not returning anything in the function here, so we say return C. So that C is there. This is a simple message. Count I is equal this, and then so the T and S, we just have to say return, but instead of this, we say return. Let's see if we can return more than one value. Normally you can't, but let's see if it returns print I count. And then I count is there. Save. And then command line. Yeah, the return has to be a different type of a return here. So, and there we have to say that character is there, print I. Let me see one thing here. For I is equal message, if I return print sub I, return a count actually. Count, we just don't want anything to return the count here. And then print, here we could just say, yeah, print, and then put the word, the T here, the count for it will be printed, and then print the T here, and then count for it, and then S, count for it. There you go. But they did not go to the actual number because T is, these ones, the count is not global. The count is losing it. Let's see if we just say global here, and then global count is equal to invalid count. Yeah, we cannot initialize it the same number twice. So that doesn't make sense here. And then if we define it outside of the scope of the function, count is equal 0, and then do that. Count, line number, local variable count, reference before assignment. That makes sense. Okay, sorry about that. So this one, I'm gonna move it here where it was defined within the for statement. And the reason we lose the scope of it here, because when we return it in that statement. Let's see one more time here, and then I'll just jump into to the rest of them. None, yeah. So I'll fix this one after. I just need to look into the code to see how I should return it with the indentation of this. It's gonna get fixed, and then the number of return. Right now the function is returning, but is saying that none because we have to define this within the scope of it. Read count. Yeah, this is definition of the function. Outside of functions. And this will still say none. Yeah, let me fix that one after. I just want to continue covering this one. My mind is thinking of the other ones as well. So type string for.py. This one basically it is just printing for a range of the decimal numbers. Is going to print the ASCII character for it, and for that decimal number, and then the character, the actual character, and then later on I'm using the for statement again, but this time I get the ordinary number of that one. So if I just do, as you can see, the ordinary here, I give an example of ordinary of A, will just print this A, and then character of 65 will print the 65. So 65, one is going to give you the ordinary, and then the ordinary gives you the number equivalent there. So let's just do, this is Python 4. And there's some non, like bill characters and other ones. That's why it's because it's 0 to 256 characters. We're printing them. And as you can see, the first ordinary of A is 65, and then character of 65, it gives you the ordinary of A, the letter A. So when we convert it from one digit, some of these ones, or non-visible characters that are not shown as spaces or something, or those spatial symbol, but then starting with 65, you can see the uppercase A and the 66 is uppercase B, and then the lowercase are 96 or something, 97 ASCII character, like 96, 97 is A, 98 is B, and so on. And then dollar symbol and all the other ones are there. So one type I print the ordinary, and another one is there. There's also some assignment that is related to this. I ask you to do that one. So it is pretty simple. You just go Python and then say, for example, character char of A, char of 65, let's say, gives you A, and then ordinary of A is going to give you 65. And then similar, like B is this 66, and then character of 66 is B. So the same thing, if you do it through the loop, you can get the same thing within for all that range of 256 characters. Type a string 4.py. You can see it is basically, it goes for decimal number in range of 256, and then I print out the this. If you don't want to print any of them, you could just do it like this. For Python, you could say for decimal number and range of let's say you want to do only a range of 10 characters. 10 characters are not going to make any sense. I'm going to do 100 range of that. Then you say print ordinary of or this one, I could say ordinary of character of decimal number. So if I print that one, I didn't close one of the brace, you could do that. And then similar to this, right here, if I just do ordinary of dn and then close it there, sorry, expected out of ordinary, I had to do decimal number. So for range, and then just print the character of that. Those are the ones are there. And if I just do the opposite of getting that range, then this one has to be character of that. Not sorry, ordinary of that one, and then print character of that to get the numbers. What did I do? Ordinary for the n. Ordinary was giving me that. I need to get the character of that. This one give me that one, and then CHR, and then expected string of length, but yeah, so I have to convert this one to a string. Actually, no, print this one and then print this one on a string, because it is expecting a string variable, but I have to do this range of this first and do a string of that and that, and then but end found. Let me just see one thing here. Exit out. More string 4.py. So on this one, we are printing a string of character of the n. There's no ordinary of character of the n. Order of character of the n. The n is already there. Python, and then we say for dn and range 100, then print ordinal of character of dm. Yeah, that will give you that. And then the other one was, we already printed out the string. So let me exit out of this. And then string 4, we did that. So let's cover file IO, chapter 7. On chapter 7, store.py, we have a number of files. So one of them is a read file, and the read file, basically when you do file management or file IO, the file system has a number of file kind of on the system, whether it's a file, whether it's a directory. Like this one is a directory, but the directory is also on the OS level. Let's consider the file. And then a file by itself could be a text file, could be a binary file. So if I just want to just do help, this help is there. And then if I just say help greater sign help.txt, now I just created that help.txt, which is the contents of it is this. So this is help.txt. Now if I want to just manipulate something with .py, read-file.py, basically in this file, I'm using a file descriptor file handle to open this help.txt as read mode. This R means dash read mode, W means write mode, and then RB for read in binary mode, WB and read in binary mode. And I mean WB is a write and binary mode. And then in this case, I'm opening this file as a text and read only mode. And then I'm doing a counter with 1. So the first line number would be showing 1. And then as I go through each line, I'll increment the 1 to 2 and so on until the end of the file is reached. And then at the end of the file, because I open file descriptor here, I have to close it. I'm responsible, if I do this syntax, I'm responsible for closing this file. Otherwise, there will be a lot of file descriptor open that no one closed it, and then the operating system has to do a later garbage collector, or there would be memory leak on the system. So it is important to open file descriptor and close it as there. But there's other context management of Python, which you use the with statement. You don't have to close it. I'll show you that one as well. Right here, when we do the file descriptor with open, we are opening this file, help.txt, but this is relative to the path where my module or source code is. So if my source code is on this current directory, help.txt has to be on the current directory, because I don't have any path in front of this, or any trailing information saying that where to find this file help.txt. Since it's in the current directory, there's a file called help.txt, and that's the content of it. So this other one, where we're looking at it right now, is the Python script that it says, okay, open this file, then go to a for statement. For each line in the file and file descriptor, go ahead and do a write stripe. So the new line character at the end of it will be deleted. Would be deleted, and then print the count and there, and then count +1, and then close it. So this is basically read the contents of that file, but also put a line number in front of it. Every time it goes there, it prints out a line number. So as you saw this one, now if we run a script called read-file.py, it will print that file, but notice that it has a line number in front of it, and every other statement is there. So that's for that file. And if I just Let's do the second one, the rf.file, more rf.py. This is reading a file similar to that one, and this one does a file descriptor, and this one it does a dir.txt. So the contents of that file versus this file is reading at contents called dir.txt. So if I say rf.py, it will read the dir.txt, which is this file, and put new line characters in front of him, says there are 13 lines and these are the files in it. So, and here there's one thing important that when I look at it, I'm just printing line as I read them, and then nothing else. And then just counting the line number and also printing the line numbers. And so that's what this, let me do dir star.py. And here, let's go to, this one is a binary, but let me go, before I do these two, for writing file. So more wf.py, this wf is opening it, one file for reading, and then one file for writing. So in this case is basically make a backup of this file as a dir.backup.txt. So let me delete dir.txt.back in case if that file is there. Now you see dir.txt.star, only one file is there, right? So now if I run this script called wf.py, this one, if I run that one, it's gonna just read the dir.txt and it's gonna make a copy of it as a dir.txt.back, because I'm saying that open this file descriptor 2 as with w writable, then set up a counter is equal 1 for each line in the file descriptor 1, which is the first one. Read each line and then increment the count. It will do that one, and then it prints it. But I'm not printing the line number, the count. I'm only doing the count is in this case as unnecessary. So and then as I go, I finish, I put the new line characters. So it makes this copy of it as exactly as the first one. And then after I am done with them, I have to close the file descriptor, both of them myself. So I run this one, wf2. It just created, and then it puts the line numbers here in front of it, and they create that dir.txt2. Sorry, let me see dir, yeah. So this one now, dir.txt.back, it is the same copy of the other one. It just created that one. If I do a dir of star, you can see the timestamp of this file that just got created, dir star, sorry, dir star. Yeah, the timestamp of that one is today, and it is at 8:27 just now. It created at 8:27. You can see it's 8:28 now. If I just run the same script again, this one, and then run that date, I'm sorry, the time, and then that, and then dir star, you can see that this file got at 8:28 modified. And then this one is same size as the other original one. If I look at the dir.txt and dir.txt.back, they're both the same file. So that's how you make copies of one file. Like I could also do the copy dir.txt as new.txt and then new.txt and dir.txt and dir.txt.back, all are the same. So operating system, you can use the copy command, but you can also use this command here, wt. If I delete dir.text.back, then I say run the W, this one. It just created the dir.text.back. Now, and this one is already there. So I type in it just there. And if I look at the directory, the size is there. So this is how we make a copy of one file using Python, reading and writing to files. So now let's look at another Python example, WF2. What is this one? This one, WF2.py. On this one, I'm reading the file text and then opening this one with W. So file handle descriptor lines as well, and then this one I believe I'm doing the line number as well, and then the new line. So dir.text, and then this one is making a backup copy of it as dir. So WF2 is the same as WF, I believe. Yeah. More and dir.text.back is the copy of it. Okay, so now store.py. Let's go about this one, simba.py. Simba.py, if you look at it, basically simba.py. This is my daughter's cat, and our cat, basically. She loves it, and then we just call it Simba. So the script, we have a picture of Simba.jpg. If I open like here I go Simba store, and you see that there's a JPEG file, and let me delete this copy version. It's not there now. We only have the py and then this. So the Simba.jpg is stored. Simba.jpg is the picture of the Simba cat, or a cat, and you can see it's a beautiful cat. It's a brown color. If I just go on big size of this, you can see this cat. But then the nice thing about it is very quiet, very nice, and very understandable, communicate pretty well, very smart cat. And this one, if we look at the symbol on this one, I want to just make a copy of this one. So like here I could use the operating system called simba.jpg and then say new.jpg. I'm sorry, copy. I wrote something different than copy. Copy. So now I could say start a new.jpg. It is the same file, because on the OS you can do that one, right? So now if I just say delete a new.jpg, and then I only have one file of Simba, I want to run this Python script, simba.py, type simba.py. This one is basically make a copy of it. So sometimes you click on your iPhone or something, say save as or copy or duplicate. So your Python script could be just saying that whatever image I have, make a copy of it. And so in this case, I'm giving the name of it as what it is, but later on we could teach you on the Cis passing argument from the cis.args, and then that way you don't have to hard code the name to the file. So it could be whatever the name is there, you just pass it on as a function and run it. The reason I'm not including it now is because you still have to learn the basics of how to do these file handling. And then later chapters, we're gonna do examples of it with modules interactivity. So at this time, let's just run it. We say simba.py, and basically now we have an image of Simba copy as well. So this is the copy. And notice the size of this one is the same as the size of the copy. So the copy, I could start it, and we just made a duplicate of it with the name as that. Notice how the rendition, everything by Python, how smart it is doing it. And the reason it is doing it that way, so I'm just saying open this file as read in binary with the file descriptor. Then with the with open statement, let me clear the screen a little bit. So clear the screen and more simba.py. So here I read the image as input with file descriptor and read binary mode. Then once I do that one, I'm going to open another one for writing it. This one, WB is the mode that I want to write to, the file descriptor 2. But then one byte at a time, I want to read from file descriptor 1, which is the input file, simba.jpg. JPG, and then read one byte at a time. So read, if I just don't put a 1 here and I say read and then left parenthesis, right parenthesis, it reads the entire chunk at one kind of chunk, and it will read it, the whole thing in one shot. I don't have to go through a while statement. But I wanted you to understand that I can read the first element, then I could read the next element, till I reach end of file. How do I know it's not end of file? If the length of byte is greater than 0, then I still have an element to read. And then every time I read it, on the file descriptor 2, I'm going to write that byte. So it makes the copy for it. And then at the end, I'm going to also read the file descriptor one more time, because every time I have to go to the next element. Otherwise, this will be an infinite loop. So within the while statement, in order for this to become false, you have to do this statement to make the length of byte at some point fail to be greater than 0, which you reach the end of file, then it's going to do it. So this is a data script. I have one more script I'm going to cover, then we are going to jump in back to the Python interactivity. So this is already done, so let me close this and maximize this window. And there is star.py. Here I have another image. My daughter painted this one. She's a great painter. She did so many nice art every time at a very young age. And then she is doing these. So this image, she painted of a soccer player that he plays with my son at the same place where they coach. And that player is actually a professional player for LAFC. His name is Latif something. Let me just check it out. Where did it open? Oh, sorry. I did a start with Python, so it actually already created that paint copy of it, because I run that one. When you say start the .py, it actually ran it and it just created that one. Let me delete the painted this.png. Show you first. I start this PNG painted.image. This is the actual image. So in order for me to duplicate it, this is the image. If I go a little bit big, his name is Latif Blessing. So it was the first 20 minutes, this was hit 444 times. I'm sure that on where he puts it on the Instagram, my son is coaching with him on this, or playing soccer with him on the A4 Kids, Advanced for Kids Soccer Academy in San Dimas. It's really good academy for youth, children's under, actually it's from 8 and up, or 7 to up, to 16 or 18. Some kids are there, a youth generation. But the idea is to say, well, they're doing this one in order to promote soccer and for kids and everything on the community, to train more people. But you see the art is really nice, right? So she drew this one, and I just want to use this image as a binary image to see. We saw the cat as which was an image that was taking a picture. This is an image that was painted. As you can see, the painted image, the extension is PNG. I wanted to see how my Python program is going to handle the PNG and make a duplicate of it. So if you write a apps and say that all they have to do is click on uh, duplicate, or duplicate, or maybe save as, or make copy of it, then they could run it like this. So if I just say, for example, director star.py, I could name this one, copy this, the py script. I could say duplicate.py, and then the content of it, the duplicate.py. If I just call it the duplicate.py or sadaf.py, as soon as you run it, it will do that one. But duplicate.py will be a button that they could press, and then automatically whatever the image that is passed on, it will make a copy of it. So right now, a star copy is there for Simba, but not for painted. So if I say duplicate.py, and now I run the same command here, dir, and then I just created the image of that one. Now if I say start this copy image, it should be opening the same image, same painted image, without any issue, and it does. It is opening it, and you can see it is there with all the text and everything, all the icons, everything, the same thing that was there as the original drawing. So Python is reading it in binary byte by byte, which is one character at a time, one byte at a time, and it manipulates it. It's really nice. Type duplicate.py. So what I need to do is, for a later class, maybe I could just make sure that this image, I can pass it on. So I could say, for example, duplicate.py, and new image, or whatever I type in here, wahid.jpg, and then it will copy that one with wahid copy of the JPEG, and that kind of things. And that will be using Python Cis modules. So Cis modules, as you can see, if I do import Cis, dir of Cis, it has a lot of arguments. So sys.argv currently is pointing to nothing because I did not pass on anything to it. And if I just go to Python and pass on to something, and then look at the argument that I passed on as image, and then sys.argv will be there. And then as an example, I will show you on my previous semester, I taught something here. Let me just go one more directory here, and then 12, and then a spring GTTS. So here, like text to audio, right? I think I call it text to audio .py, and text to audio.py. If I look at this one, more text to audio.py, right here, you can see that I'm passing different ways of doing it. So here I'm looking at the length of the argv, sys.argv. If it is less than 2, then I say please provide an input file. And then otherwise, I'm going to say whatever they provide as argv sub 1, I look at it, add it to extension of MP3 to it, and then to create an out file. And then based on that one, I run this one, the main. And then here, when I'm coming back to the data file here, this is the Google text-to-speech recognition. So I'm getting an input file from the user, whatever the input file is, then based on that one, I will read the data for it. So let's say directory store.text. Let's do a small one, like this one, Ronaldo. So this one is Ronaldo.text. If I just have more Ronaldo.text. So if I have this text and I want to just run the audio for it, in this case, I could run my Python script, say text to audio.py, and then give the input as, if I just say like this, it says you need to put the argument to it. It's not recognizable. So I say Python here. It says that Python cannot open text to audio.py, no such file, text to audio. So now it says that no module GTTS. It is basically the pip list. The GTTS is not installed here. I have to install that one in order to get, you can see this GTTS is not there. So I could say pip install GTTS. And then since I'm on the command line, sometimes GTTS is going to just fail because of permission denied thing. If it doesn't fail as a permission denied, yeah, it did, because I have to open up command prompt CMD and then an administrative privilege. And then say yes here. Then I go here and then says CD to users, Wahid, and then Pasadena.edu, and then Spring 12 Spring, and then GTTS, and then pip install GTTS. Could not install package to environment. It's import 443 max. It tries to exceed the URL. Okay, so that naming was all uppercase and T's. That's why it has to find it with that name. Unfortunately, sometimes when developers tried it, they don't think of, make it so universal or easy to find. If you give a name of package NumPy and the person type it NumPy, it should find it. It should not be specific to certain characters, because there's so many names there. You could do a search and find the exact name there anyway. So let's do this. We did that one. Now do Python text to audio.py, and it's gonna look for, I did not provide any input file, right? So in this case, the Ronaldo.text is there. I'm gonna give that input as a Ronaldo.text. And in this case, Ronaldo.text is the input. The cis argument, I don't know why I type in D here. So that Ronaldo, now it is opening a MP3 player and read that text for me in audio.
Cristiano Ronaldo dos Santos Aveiro G-A-Y-A, European Portuguese, born the 5th of February 1985, is a Portuguese professional footballer who plays as a forward for Serie A club Juventus. Captain of the Portugal national team, often considered the best player in the world and widely regarded as one of the greatest players of all time, Ronaldo has won 4 European Golden Shoes, both of which are records for a European player.
So I'm going to stop it, and right here, if we look at it in that file, whatever is inside that file, Ronaldo.text, whatever is inside that one, it was reading it for me, line by line. And then the PEP list, now it will show that the Google text to search and all dependencies along with it are installed. You can see they're installed. And in addition, there's more packages like request and other ones that were not previously there that got installed as a result of that PEP install. So when you do that one, inside this module that we were doing it with Python, this syntax, we did, right here, let's do the text to audio.py and then run Python in front of it. And then we could just say, and instead of Ronaldo, let's say we say Messi.text. If Messi.text, I have it there, it will play that one as well. And Messi is also the best player in the world. He's actually the best.
Copyright is Messi Portuguese. Note 1. Spanish pronunciation. LJOE diaresis nil and E diaresis date 3/4 ECE diaresis Messi. About this sound listen. A, born the 24th of June 1987, is an Argentine professional footballer who plays as a forward and captains both Spanish clubs. Barcelona, the Argentina national team, often considered the best player in the world and widely regarded as one of the greatest players.
Yeah, I think he is the best player in the world. Cristiano Ronaldo, previously Maradona, and there's other players that were great players, John Cruyff, Pele, and Ronaldinho, and other ones. But Zidane is one of the greatest players, and there's a lot of other ones, and that we can name all of them. But Cristiano Ronaldo and Messi, both of them are the best player as of now. The file that when we do the Python things, look at this, it reads this text to audio and that information. So this one was taking the argument, this Python script. If I was on the module cis, argv1 will be pointing to this. And as you can see, text to audio.py, text to audio.py, I'm doing this v sub 1. And the argument is there. Then I'm going to just create an MP3 based on our argv sub 1. Whatever the input text file is, I make a MP3 player for it. Similar to that one, I'll just add on more code to our other functions to just make it read files and other ones, binary format. And then this is the line that I could just add it. Length of sys.argv, if it is less than 2, then basically you just say not enough parameters passed on. Otherwise, argv sub 1 already has that, and you manipulate it. And so let's go back to the other one. So right here, if I go back to lectures, CD to lectures, CD to lectures, sorry, Pasadena, edu lectures, lecture, and then here I could go to 12 star summer, and then lecture, and then go to chapter 7, and then here I could dir of this. So let's do one of them, like Semba dot more Semba dot py. So this one, for example, it reads that file. I could just say Python and then say import Semba dot Semba py. When you do the import Semba dot py, as we saw last week, it actually created a cache for Python compiler version of it, a bytecode for it. But here I could do a dir now, and then the package that I run, Semba, is available for me, that module. So now if I say dir of Semba, and notice inside here, this file descriptors, byte, and other ones are all available. So now if I do a dir of Semba dot file descriptor to see what are on the file descriptor. As you can see, for file descriptor, there's all those statement read line, and so on, and seek, and then the tell to see where my file pointer is. Seek is to just go read element by element, write to write it, and then read line to read the entire thing in one line, and then read is read one line at a time, read the entire chunk and there, and so on. All these file descriptors availability is there. Similar for FD2. Same kind of methods are available for it because they're both file descriptors. So if I just say print file descriptor dot read, and then this one, name file descriptor is not defined, so I have to do Semba in front of it, because Semba is there. The read of a closed file. So the file, this one is already closed. Since we open it, when you open it, the file is already closed, so it's true. You cannot manipulate a file that is there. So when I say, for example, let's say I exit out of here, and then type read file.py. As an example, if I just say Python here, and then I say file descriptor is equal, and then give a name of a file, say open, the file name that I want to read is dir.txt, let's say. dir.txt, and then read it as read only. Now if I say file descriptor.read, it will just read the entire thing as one line. If I say file descriptor.read line, because that file is already read lines, it is already pointing to the end of it. When I did the file descriptor originally, right here, I could have done this file read line, read lines. This would still read it, but if I just read it again, it's not going to say you already reached to the end of the file. So the way I could tell is print file descriptor dot closed, then that would say false. It is not closed, but the file is still open, yet I cannot just read any other element from it because I reached to the end of the file. So in order to read the next element, start back again, I have to do a file descriptor dot seek and then put the 0 element, start fresh, and now say do this file descriptor.seek, and then now um, do the same thing here. I read it again. I read it again, it's going to be empty. I read it again, it's going to be empty because I reach end of file until I just say, okay, let's do the file descriptor point to the first element, file descriptor seek, and then a 0, and then I could do another read and lines, and it will be able to do it. Again, if I do another read, it's already end of file. So when I do the seek, it is available. Now if I just do a tell to see what is my file pointer point to, it says that I'm pointing to this. If I just read it or the whole thing, and then since I'm reading it and it's pointing to the end of the file, if I tell a tell file descriptor tell, sorry, I have to find that one, file descriptor tell, and then that it will just say you reach to the end of it. So I could just say read from a portion of it. So I could say file descriptor seek, I could say read maybe from 500 only. Now the file descriptor, I only read the last 33 bytes. So I could say this read bytes, it only reads the last 33 bytes. And then now I read it again, it's going to be just empty again. If I just set this one to seek to 0, meaning that it starts from the first one, then it's going to do that and read the whole thing. So another thing that you could do is when you open it for writing, for example, let's say a file descriptor, I open file descriptor. Whether I use a file descriptor 2, I open open a new file, I say new file dot text. This file doesn't exist, but I want to open it for write, on write purpose. So now I open it for write. If I just say file descriptor 2.seek to just say this one, right now it is pointing to the first element. If I just say tell as the get rid of this 0, it will say there. So now file descriptor 2.write, I say this. If I just do that one, now I put that letter this, and let's say just say import OS. I want to just show you as it goes there. So now os.system, if I say dir of and the new file.text, that's what I named it. It is already there, but it's 0 byte because I have not closed it. So if I just say type this one, this file is open in the process, but has not closed to it. Even though I wrote the word this in it, I can add more to it, and I say, let's say just I write another word, this, and then also write that. So this already got modified by the word that because I haven't closed it. But if I do f2.close, and now I say dir of this one or that file, you see that this and that is written there. And then both of them are appended there. So now if I do this, that file is 8 bytes long. But now, if I just open again the same file descriptor, this time instead of opening it as a read, I'm going to say with a statement. With open, and then a new file.text. I want to open that one with write permissions. So I could just open the same file as a file descriptor name, okay? And then say file descriptor dot write, and then since I'm going to do this one, say Wahid, write Wahid in there. And then this time, if I just press enter, file descriptor, because I'm using with statement, the context manager of Python automatically closes that file and writes the 5 bytes there. So now if I just say that, it's 5 bytes long. And if I look at the content of it by doing a type, you can see it wrote Wahid. So that word was replaced by this. So now watch, if I just do one character, open up this with open statement there, and this time I'm gonna just say I go file descriptor .write, and then I say only change the W to H for Wahid. No, actually, W to let's say so Wahid. I'm gonna put and instead of Wahid, I'm gonna say S for Sahid, something like that. So let's say we want to just change the first character only. You could do that and then run this one. Now on the same file there, S0, but the other characters are also overwritten because we opened it for write. Okay, so now this time I'm going to open the same characters for append, A plus. Append, that would just say write it there, and then I just change this one to Wahid, Wahid, and then now go print it. It has the S and the, as well as Wahid. So the S was already there because we're appended, we did not override it. So it's important the mode that you're opening it. Now if I say file descriptor.mode, it says that it's append for read and write, appending it. And then file descriptor.name, what is the name of it, you could see, and that's the one. So there's a lot of commands you could do with it, and here's the information here. It is 9:07, and let's take a 10 minutes break, and then we come back. Let me just, another 3 minutes, we cover Cis Modules. I believe I did that one, but I'm going to do that. So let me do one more thing, sorry. os.system, I'm going to clear this screen here. Okay, and then say import a string. A string is a module. So dir of a string give you these variables. So like for example, a string dot octal digit, X digit, ASCII uppercase, all of that one you can print it by saying print a string dot ASCII lowercase. So that will just give you all the lowercase characters, and then uppercase similar. So and then ASCII or capital words. This is a function, and then you just capital cap words, and this is a function caps at this. It might just take one argument, whatever it is, to capital the first word there. So I could just say, and this is a, okay, let's say, and this is a test. So it should make this T uppercase, is uppercase, if caps words the first word there. I just have to close it. Yeah, this is basically that. So you could say this, and if you change this string to something else, simple test to see if it capitalize all words. And then you can see that it capitalize all words, the cap words. So then you can also have the printable characters, for example. This one, you can get a list of all printables. You can see that. And then octet digit, octal numbers, similar hexadecimal numbers, octal 0 through 7, and then digit. X digit is 0 through 9, and then 10 is 8 through F through 16, or 15 actually. But this base 16 because 0 through 15. You can get a lot of these information, and then help of the function string itself give you all those details of, you can play around with all these ones. If you want to say a string.white spaces, it prints the ASCII with white space there. Okay, so exactly 9:10. Let's take a 10-minute break. You come back, I'll give you a quiz, and then you can do the quiz online today. Thank you so much. Let's take a 10-minute break. At 9:20, you should be back for the quiz. Thank you all. That's good, 11 people with me. Let me stop the recording now.